Good evening, everyone. Good evening. Good evening. Good evening. So, I hope you all have attended classes of PNC. So, tell me if there is any student who has not attended classes on PNC. Okay, it's good. Okay, now, so in case of probability, good evening. All the concepts of PNC comes into picture. So, in order to compute probability, we just have to focus on number of favorable events divided by total number of events. So when it comes to total number of events, I always say that this is my sample space. So out of my total sample space, whatever the favorable sample space is there as per the given condition, we have to choose the values. Good evening, good evening. So in case of probability, we just need to focus on this basic thing. So the different questions that are based in probability involves cases of coins or cases based on rolling a dice or cases which are based on drawing a card or you can say drawing a ball from a given bag or boxes, right? So they are the basic cases on which majority of the questions are based when it comes to any exam. So when it comes to a coin, we all are aware of that the total number of possibilities in a coin are only two. It is either a head or a tail. So if we toss one coin, in that case my total sample space is two, which means there are two possibilities. If we toss two coins, then the total possibilities are going to be two square. If we toss three coins, total possibilities are going to be 2 cube. If we toss four coins, it is 2 raised to power 4 and so on. Likewise, when it comes to rolling a dice, as there are six faces of a dice, so the possible outcomes are 1, 2, 3, 4, 5, and 6. So it is a standard dice wherein the numbers are 1 to 6, but you can also be given any dice with different numbers. So the basic concept never changes. So we can say that for one dice, the total possible outcomes are 6. If two dice are rolled, good evening, good evening. If two dice are rolled, so total number of outcomes possible are 6 square. If three dice are rolled, total number of outcomes possible are 6 cube and so on. When it comes to drawing a card from a pack of cards, so in all there are a total of 52 cards. Now these 52 cards are broken down into two parts. One would be cards which are numbered and cards which we call are honor cards. So we all know that the numbering on the cards starts from 2, 3, 4, so on up till 10. On the other side, the rest of the cards fall under the category of honor cards, which is Ace, J, Q, and K. Right? So we are having a total of four suits in case of cards. So guys, can you tell me what all suits are there? How many of you are aware of how many suits are there? Good, Chinmay. Yes, they are four suits. Suits. I'm asking their names. What are the names? Like there are two black and there are two red suits. So Subhadip, dice is not a part of this. So when it comes to black, one is going to be spades and the other is going to be club. When it comes to red ones, so one is going to be hearts and other is going to be diamond. So they are the total four suits. I hope this part is clear. No, Shubhadeep, diamond suit is never called dice. So we always call diamond as diamond only. So it never looks like dice. Dice is a 3D figure, right? So dice looks like this. So maybe it can be a local language. So kindly update it. So Amir, these are the only things we are discussing, the possibilities. So when you toss a coin, either you get a head or you get a tail. So we were talking about the total outcomes possible when you toss one coin, there are two. When you toss two coins, there are two square which are four. When you toss three coins, there are two cube and all. So when it comes to rolling a dice, so the total values possible on all the six faces are 1, 2, 3, 4, 5, 6. So we can say on rolling one dice, total outcomes are 6. On rolling two, 6 square. On rolling three is 6 cube and all. Likewise, when you draw a card, there are a total of 52 cards, right, which are divided in two categories. One would be the cards which are numbered, other would be the cards which are called honor cards. So numbers on the pack of cards is 2 to 10. So honor cards are A, J, Q, K, and there are a total of four suits, which are going to be two black, spades and club, two red, heart and diamond. That's it. Pranshu, when it comes to cat, so at least one question of probability will be there and at most two. So one or two questions is a trend when it comes to probability, right? So likewise, when it comes to PNC, around two to three questions of PNC will be there. So we can expect at least two and at least one from this part. Is it done, Pranshu? Okay, so let's move ahead. So now let's discuss few questions to start with. So let's say if the question says that two dice are rolled simultaneously, so find the probability that one of them shows a number which is at least 4 and other shows at most 3. So if two dice are rolled, we know that the possible outcomes on the face are 1, 2, 3, 4, 5 and 6. On first dice, we are required a number which is at least 4, which means the outcome should be either of 4, 5 or 6. On second dice, we are required at most 3. At most 3 means number should be 1, 2 or 3. So on first dice, if we get 4, 5, 6, which are my favorable possibilities, any number out of these three, if comes on the first, it becomes a favorable case out of 6. So the probability for first dice for getting a number which is at least 4 is 1 by 2. Likewise, on second dice, again there are three possibilities out of 6. So getting any of the three numbers out of these 6 gives us a probability of 1 by 2. So in order to compute overall probability, my answer is going to be 1 by 2 into 1 by 2, which comes out to be 1 by 4. So 1 by 4 is the probability, which is the required one in this case, such that one dice shows a number which is at least 4 and other shows at most 3. So tell me guys, is this part clear to each and every student? Okay, okay, okay. So while solving questions based on probability, what I just did is a very common mistake which majority of the students do. So that's why I did it, because please never ever do this particular thing. It goes wrong. So I'm repeating the question now again. Here the question was that first dice is required either of 4, 5, 6. Second dice is required either of 1, 2, 3. In order to compute probability, we have to go with total possibilities in the numerator, which are favorable, divided by total possibilities, which we will get on throwing 2 dice. When you roll 2 dice, total outcomes possible are 36. When it comes to favorable cases, please do not multiply probability in both the cases. You just cannot multiply probability in each and every case. So we need to understand when to multiply, when not to multiply. Here the question talks about when you throw 2 dice, one of them shows a number which is at least 4. So if 4 comes on this number, on second number it can be 1, it can be 2, it can be 3. Likewise, if on first dice the number is 5, on second again it can be 1, 2 or 3. On third dice, if it on oh, sorry on the first dice if it is 6, likewise on second dice it can be any of 1, 2 or 3. So my total outcomes in this case are 9 in number, right? So in this case, when you simplify it, we need to focus on one more part along with it. That if 4 is on first dice and 1 is on second dice, this is one possibility. It can be other way around also. It can be 1 on first dice and 4 on other dice also. Right? So for each and every possibility, there are two ways. So we need to multiply it with 2. If you do not focus on these cases and if you do not multiply this probability with 2, your answer goes wrong. 1 by 4 was a wrong answer, which is a very common mistake. So in this case, answer comes out to be 1 by 2. Is it clear now, everyone? Yes, Rahul, I have mentioned. So I am explaining the concept so that you can also understand why we are multiplying it with 2. Rahul, is it clear? Yes, Shivani, I am doing it again. So here I am saying in the numerator we are going to have all the favorable cases. So students usually do these kind of mistakes that they calculate probability out of this which is 1 by 2, out of this which is 1 by 2, and they take 1 by 4 as an answer. So I am saying this part is wrong, because in this case we need to understand that out of these 9 outcomes which are favorable ones. So if this is first dice, this is second, this can also be possible that these are the numbers on first dice and they are the numbers on second dice. For all these 9 outcomes, there are 2 possibilities for each and every outcome. So total favorable cases are not 9, they are 18 basically. Is it clear, Shivani? So required answer comes out to be 1 by 2 and not 1 by 4. Shivani, is it done now? Ankita, because there are 2 dice, so if you get 1 on first and 4 on second, or if you get 4 on first and 1 on second, they are two outcomes and not same. So when I'm saying that on throwing two dice, a total of 36 outcomes are possible, right? So these 36 outcomes basically include this case as well as this case. So that's why it is important to multiply it with 2 so that all cases are taken care of. Is it clear, Ankita? Because question is not saying that the first dice show a number which is at least 4. Question says one of them show a number which is at least 4 and the other shows at most 3, right? So like possibilities are either ways. It can be 1 4 or it can be 4 1. Shivani, tell me what is the doubt now? Which part you are not able to understand? Shivani, okay, have a look on next question. Again, it is on the same lines. Okay, now let's look at this. So here it says two dice are rolled simultaneously. Find the probability that the sum of the numbers on them is not 8. Please keep in mind, he says it should not be 8. So when you roll two dice, so total outcomes possible are 36. So if I have to calculate probability that the sum should not be 8, so I am going to put a bar on this. So this bar means that sum should not be 8. So we can say it is equivalent to 1 minus the probability that sum of the numbers are 8. As we know that there are going to be two numbers a and b which adds up to 8 on the top of two dice. So if we have 1 on first, then other should have 7. But please bear in mind that 7 is not a possible number on a dice. So you cannot consider this case. So if 2 comes on first dice, then 4 will be on second. If it is, 6 will be on second. If it is 3 on first, then 5 on second. It can be 4 and 4 on both. It can be 5 and 3. It can be 6 and 2. So there are a total of 5 outcomes possible out of 36 outcomes when the sum is 8. So the required probability that the sum is 8 is 5 by 36. So on simplifying this, answer comes out to be 31 by 36. Is it clear, everyone? Shivani, is it clear now? Good, good. Okay, so Ankita, again, please bear in mind, they are not the only three cases we have to consider. We have to consider all the possibilities. So 3 5 along with 5 3, 2 6 along with 6 2. Right. So when we consider all the possibilities, only then we are going to calculate the right probability. Otherwise, it will go wrong. Okay, now let's do it. So here he says three fair dice are rolled simultaneously. Find the probability that the first dice shows a composite number, second shows an odd number, and third dice shows an odd prime number. Now guys, please keep in mind, in the previous two questions, nowhere it was mentioned about first dice, second and third. Now the position of all the three dice is fixed. So when it comes to that, on first dice, the number required should be composite. So we should have proper clarity that out of these six numbers, tell me guys, how many composite numbers are there? Good, good, good. Okay, please bear in mind that 1 is neither prime nor composite, right? So there are only two composite numbers which are 4 and 6. So on first dice, my favorable cases are these two out of 6. So required probability is 2 by 6. In second case, I am required an odd number. So odd numbers are going to be 1, 3 and 5. There are three favorable cases out of 6. In case of odd prime number, so 3 and 5 are the only odd prime numbers out of 6. So required probability is 2 by 6. On simplifying this, the 6 and 6 got cancelled out. 2 3s are 6 got cancelled out. Answer comes out to be 1 by 18. I hope this is clear, everyone. If you have any doubt, do let me know. Good, good, good. Any student having any doubt? Good, good. Now I hope you guys are able to understand the difference between previous two questions and this question. In the previous two, the position of dice was not fixed. In this question, the position is fixed for first, second, and third. Okay, now, so in the very same question, now I'm going to change the statement. Now, the statement is three fair dice are rolled simultaneously. Find the probability that one of the dice, yes, Ankita, one of the dice shows a composite number, other shows an odd number, and third one shows an odd prime number. Come on, guys, be quick. Okay, so I'm getting varied of responses. Okay, guys, now let's have a look on this. Now, because there are three numbers, let's say first dice shows A, second shows B, third shows C. So now in this case, the order can be any. It can also be A on second, B on third, and C on first. Or if I talk about total arrangement possible, please keep in mind if A, B, C are distinct, then it is to be multiplied by 3 factorial. Otherwise, you cannot multiply it by 3 factorial. Guys, are you able to understand this thing? Like if I say for one of the dice I am required composite number which can be out of 4 and 6. On other dice I am required odd number which is out of 1, 3 and 5. In third case I am required an odd prime number which is among 3 and 5, right? So you cannot multiply it by 3 factorial straightways. Because when you get a case like 4, 3 and 3, the given condition is taken care of. But the total number of ways in which this can be arranged are only 3 and not 3 factorial. Guys, is this part clear to each and every student? Shubhadeep, is it done? So now while solving these kind of cases, it's very important to look forward to the cases which we are getting now. So case one is going to be when the numbers on all the three are distinct. Now we can clearly see that the numbers can be distinct if we get 4 and 6 on any of the dice, or if we get 1 on any other dice, and out of 3 and 5 any value on third dice, right? So the moment we are going to get 3 on this, if we get 5 on that, so that is going to be again different case. So if we consider 4 and 6 on one of the dice, and on this dice if it is 3, and on other if it is 5, it will work out. Or on this if it is 5, and on third one it is 3, again it will work out. Guys, is this part clear to each and every student? Now tell me, is there any other possibility when the numbers on all the three dice are going to be distinct? Shivani, here I am saying case 1 is when the numbers on all the three dice are distinct. So if you get 4 or 6 on first, because 4 or 6 is not there in remaining two. So if you get any of the two numbers on first, and if you get 1 on second, on third it can be any of 3 or 5. But if you get 3 on second, then in third it has to be 5. Likewise, if you get 5 on second, on third it has to be 3. Likewise, when repetition is coming in picture, so on one of the dice if it is 4 or 6, on second dice if it is 3, and on third dice again if it is 3, so then a repetition is taking place here. Or if it is 5 on second and again 5 on third, so again repetition is taking place. Is that clear, everyone? Shivani, is it clear? Now we have to calculate the probability. Shivani, tell me, have you attended class on PNC? Shivani, have you attended class on PNC? Then they are the very basic things here. I'm just framing the cases of the possible outcomes. So if you get 4 and 6 on first, 3 on second, on third again if it is 3, only then duplication is taking place. If you get 5 on second and 5 on third, only then duplication is taking place. Rahul, I am coming on the same that I will discuss. I am just writing all the possibilities right now. Right? Now when it comes to calculating the number of cases now. So if 4 or 6 is there on first, 1 on second, 3 or 5 on third. So first of all, we need to think of how many cases are possible. Something like 413, 415, or 613 and 615. So a total of 4 cases are possible. And then all the three numbers can be arranged in a total of 3 factorial ways. Likewise, in second case, it can be 435 or it can be 635. So these two cases can be again arranged in a total of 3 factorial ways. So when it comes to 435 or 453, we have already considered these cases in the previous one, so we need not recount them. Right? When it comes to 433 or 633 or 455 and 655, they are a total of 4 cases. Now 433 or 633, 455 or 655, can be arranged in a total of three ways. So now they are going to be my total number of favorable cases. So 4 into 3 factorial is going to be 24, 2 into 3 is 6, 4 into 3 is 12. Addition of these three comes out to be 42. So these 42 are my favorable cases out of 6 cube cases. So once 6 got cancelled out here, and required probability comes out to be 7 by 36. Is it clear, everyone? Rahul, if there is a question wherein we have to frame cases, you just cannot skip it, right? So don't get confused, just follow the process. We basically need to learn these things wherein majority of the students commit mistake. The only reason is that they are required quick answer. So do not focus on finding quick answer as always. There is a process which we have to follow to reach our answer. Any doubt, guys? Tell me. So whether you are solving questions on PNC or probability, processes are the same. Any doubt? Still, anyone has any doubt? Tell me. Okay, then let's move ahead. Okay, now guys, give it a try. Shubhadeep, that's what like you need to focus on is that the values whatever you are getting. So in first go you have to find the right answer. In any exam you do not get multiple chances, right? So better is always stick to a plan, solve questions with very basic approach, minimal approach. The job is always easier. It is face. Just give me a sec. Is it fine, Shubhi? Come on, guys, be quick. Parvesh, this sum is never possible. Okay. Okay, guys, I think let's do it. Or you, if you need more time, do let me know. No, Lakshya. Right, Shubhadi. Okay, guys, have a look here. So the outcomes possible on the face of dice are 1, 2, 3, 4, 5, 6. So if you throw a dice, then the probability that one comes on the top face or 2 or 3, 4, 5, 6, it is equally likely and it is 1 by 6. Is it clear, everyone? Probability that any of these numbers appear on the top face of the dice is 1 by 6. But when you are throwing two dice, then first of all we have to think of what all sums are possible. So when you throw two dice, the minimum sum possible is 1 plus 1, 2, and likewise the largest sum possible. Shubhadeep, I'm talking about two dice only right now. So we'll solve 13 later on. So the maximum sum possible will be 6 plus 6, 12. Now we need to observe whether all sums in between 2 and 12 are possible or not. So if it is like 2 on one and 1 on other, 3 is possible. So 2 plus 2, 4 is possible. 2 plus 3, 5 is possible. 6, 7, 8 is possible. So then 3 plus 6, 9 is possible. 4 plus 6, 5 plus 6, and 6 plus 6, 10, 11, 12, all sums are possible. So please always keep in mind that whenever you are throwing few number of dice, all the sums are possible between minimum and maximum possible sum. Is it clear, everyone? Guys, is it clear that all sums are possible from 2 to 12? Okay, good, good, good. Now, if I want to calculate the probability that we get a sum of 2 on the top face of the dice. Now, out of 36 possibilities, can I say we can get 2 in only and only one way? So required probability is 1 by 36. Likewise, if I say the probability that we get a sum of 12 on the top face of the dice. So getting 12 is again in only one way. So required probability is 1 by 36. Now question says what is the most probable sum? So we have to find a sum through which the probability is the largest. Now my base is going to be fixed, it is 36 only, because they are the total outcomes, you cannot reduce them. So my probability will be maximum when the number of favorable cases in the numerator are largest possible. Is this clear, everyone? The larger this value is, the larger is the probability. So for 2 and 12, my probability is same, which is 1 by 36. Likewise, for 3 and 11, probability is again the same because number of possibilities are the same. For 4 and 5, sorry, for this 4 and 10, again probability is the same. For 5 and 9, for 6 and 8, probability is the same. For 7, this is the odd one out, for which your probability is going to be different now. Right, like if I talk about 3 now. Now we can get 3, Sharad, I am going to explain the same. We can get 3 in two ways, 1 plus 2 or 2 plus 1. Likewise, we can get 11 again in only two ways, 5 plus 6 or 6 plus 5. If you take 4, it can be 1 plus 3, 2 plus 2 or 3 plus 1 three ways. Again, you can get 10 in only three ways, 4 plus 6, 5 plus 5 or 6 plus 4. And you can see that there was only one way in the beginning, and then the possibilities are increasing the way we are moving inside. Right. So we got one case here, we got two here, three here, then there are more, even more. So can I say, because it is the same on either ends, my probability is the highest at the middle value? Is it clear, everyone? Like in this case, 7 is there in the middle, so the number of cases are going to be the largest for 7. So the most probable sum in this case is going to be 7 only. But here, as the statement says, that a total of 13 dice are thrown. So for 13 dice, the minimum sum possible is 13 and the maximum sum possible will be 13 into 6, which is 78. What I am required is most probable sum is going to be the value which is there in the middle. Now please keep in mind, if you throw even number of dice, then minimum and maximum value is always going to be even. So average of these two is going to be the middle number. So 2 plus 12 divided by 2 is my middle number 7. But if the number of dice which are rolled are odd in number, so minimum value is always going to be an odd value. Largest value is always going to be an even value. So in case of number of terms which are like even, because when you are starting with an odd number and ending with an even number of terms are even. So in this case, you will be getting two terms in the middle, and probability for both the two terms, because they are equidistant from both the ends, is going to be the same. Now in order to find the middle term in this case, so you need to add these two. 78 plus 13 adds up to a total of 91. So the two terms in the middle are going to be 91 minus 1 upon 2 or 91 plus 1 divided by 2, which comes out to be 45 or 46. So in the given question, they are going to be the most probable sums. Is it clear, everyone? If you have any doubt, do let me know. Ankita, here I am saying, if the number of dice are even, right, in that case minimum value will be even, maximum is to always even because it is getting multiplied with 6. So middle term here is going to be the average of these two, 2 and 12, which is 7 straightways. You got only one term. But when the number of dice you have rolled are odd in number, in that case please keep in mind that minimum value is going to be odd and maximum is going to be even. In this case, we got odd number of terms. So middle term is only 1. In this case, we got even number of terms. So because of the same, there are going to be two terms in the middle. Is that clear, Ankita? So in order to find those two terms in the middle, I just cannot take average of these two, because the sum comes out to be 91. So the two terms are minus 1 by 2 and plus 1 by 2, which are there in the middle. Good, good. Any other student having any doubt, do let me know. Good, Shubhadeep, good. Okay, so let's move on to next one. So let's do one more question here. So instead of 13, let's make it 20 now. So be quick, tell me the answer. So let's see who will give me the answer in first go. Right, Shubhadeep. Come on, guys, be quick. No, Harshita, do it carefully. Right, Aditya. No, Krishan, do it carefully. No, Rishabh, do it carefully. Right, Rahul, right, Sharad. All other are correct. Right, right, right. So, guys, we just need to focus on minimum sum possible, which is 20, and maximum sum possible, which is 120. If both the numbers are even, just take average of the two, which comes out to be 70, which is the most probable sum. Is it clear, everyone? So 71 is not here in the picture. Guys, any doubt? Ankita, is it done? Ankita Singh? Okay. So now let's try a couple of questions on coins now. So here he says five fair coins are tossed together. Find the probability of getting exactly four heads. So in this case, guys, we just need to right. So we just need to focus on one part, that if you are going to toss a coin, the outcome possible is either a head or a tail. So the total outcomes possible are going to be 2 raised to power 5, which is 32. In the numerator, we are required exactly 4 heads. So which means if there are exactly 4 heads, then there is going to be one tail on one of the coin. Again, we just need to focus on that in how many ways they can be arranged. So because these four articles are identical and this one is distinct, so the number of ways of arranging them are only 5. So required probability comes out to be 5 by 32. Is it clear, everyone? Any doubt in this? Tell me. Any student having any doubt? Okay, good. Now let's move on to question number 6. In 60 says 5 fair coin are tossed together. Find the probability of getting at most 3 heads now. So give it a try, guys. Tell me the answer for question number 6. Soumya, in which question? Right, Shubhadeep, right, Rahul. Yes, because here he has mentioned exactly 4 heads are required. So that's why we have chosen exactly 4 heads along with the tail. No, Harshita, it's wrong. Right, Subhadeep, you are correct. Rahul is correct. Harshita, it is wrong. Rishabh is correct. Aditya, it is wrong. Okay, guys, let's do it. So basically, we need to understand the meaning of at most three heads. Right, Harshita? So at most three head means zero heads, one head, two head, and three heads. So zero head means all five are tails. So one head means one head and four tails. Two head means two head and three tails. Three head means three head and two tails. So they are the possibilities which are favorable one. No, Sharad, it is wrong. So guys, whenever we are solving questions like these, we just need to focus on one part, that whether solving this part will make my job easy or solving rest of the part will make my job easy. Like whenever you are going to throw few coins, right? So we just need to focus on total outcomes possible. So out of like five coins which we are throwing, so four I have already written. Fifth possibility will be four heads and one tail. Sixth possibility will be when all five are heads. So can I say it's better to solve this part of the question instead of solving this? If we find this probability, required answer will be 1 minus the probability that we get at least four heads. So at least four heads means that we get exactly 4 subtracted, along with that exactly 5 subtracted. So we have already discussed that total possibilities are 32. In 5 ways we can get exactly 4 heads. In only one way we can get exactly 5 heads. So this is the probability of getting at least 4 heads, which is not required. Required is at most 3 heads, so it has to be subtracted out of 1, which comes out to be 26 by 32, which is 13 by 16. Is it clear, everyone? So my question says 5 coins are tossed together. Find the probability of getting at most 3 heads. So I have just written all the possibilities. At most 3 means no head, which is 0 head, 1 head, 2 head, 3 head. All the 4 cases are to be considered. So if we have a look on all the possibilities, instead of solving these 4, it's better if we solve the rest of the 2 possibilities. Is it clear, everyone? Any doubt in this? Do let me know. Okay, good, good. So in the very same case, if it is getting at most 2 heads, then guys, what is the answer? Right, right. Okay. Okay, now, so again, there are a couple of ways of looking at this information. So, the number of ways in which you can get 0 head is only one. The number of ways in which you can get 5 heads is again only one. The number of ways in which you can get 1 head Guys, tell me how many ways are there? Good, 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 good. So there are 5 ways in which you can get one head. There are again 5 ways in which you can get 4 heads. So what about guys 2 heads? In how many ways you can get 2 heads? So they are going to be 5 factorial upon 2 factorial into 3 factorial, right? Which are going to be 10 ways. So they are going to be another 10 ways. So if you observe this part again, as we did in the previous case of dice, the number of possibilities either ways are the same, right? So when the question says find the probability of getting at most 2 heads, so please keep in mind half of the cases are the answer. So it is 1 by 2. I am not saying 16 by 32. I am saying half of the possibilities are here, half of the possibilities are there. So answer is 1 by 2. Instead of giving you 5 coins, the number can also be a larger one, right? So like if I say a total of let's say 31 coins are tossed together, find the probability of getting at most 15 heads. Guys, now what will be the answer? Come on guys, be quick. 31 coins are tossed together. Find the probability of getting at most 15 heads. Right, right, you guys are right. I'm waiting response from other students as well. Right, right, good. So guys, please keep in mind when the numbers are large, the questions are relatively easier, right? In this case, he is not expecting you to count all the cases which are favorable. We just need to focus on that starting from 0 head, 1 head, so on up till 31 heads which are possible, right? So they are a total of 32 cases. So 0 to 15 is on one side and 16 to 31 are on other side, right? So either ways my outcomes are same for all the values. So number of possibilities on the left hand side are equal to number of possibilities on the right hand side. So the required answer is going to be straightways 1 by 2. Is it clear everyone? Good, good. Guys, if you have any doubt, do let me know. Okay, then let's move ahead. Now, when it comes to drawing cards, so please keep in mind, somewhere then accordingly scenario will change, then you have to count the values, right? Is it done somewhere? So if the numbers are large, examiner will always make your job easy. Somewhere like in exam, examiner is not expecting you to calculate, unnecessary values, right? So they know like mathematics, it's not a paper of mathematics, it's a paper of quantitative ability or aptitude. So majority of the questions are logical only or are required very less calculation. Okay guys, let's do these questions now. So a card is drawn from a well shuffled pack of cards. So there are a total of 52 cards. So he says find the probability of it being a jack. So guys, jack is J. So out of right, 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 everyone, right. So he says find the probability of it being a jack. So guys, we just need to focus on that how many jacks are there out of 52 cards. So we all know that there are 4 jacks out of 52. So required probability is 1 by 13. Right. Chinmay, Chinmay, what are you doing? Is it a typo error or what? Do it carefully. In B says a black numbered card. Guys, please focus on this term, a black numbered card. I always say I am not required quick answers or you should not be in any sort of hurry. Otherwise, your answers will be wrong. Just wait. Let me do it for you guys. Out of 52 cards, black numbered cards are 2, 3, 4, so on up to 9. Guys, how many cards are there? From 2 to 9, how many cards are there? Come on, guys, be quick. So there are 8 cards which are numbered 2 to 9, right? Sorry, not 2 to 9, my mistake. I have to write 10. So there are 9 numbers from, yes, yes, yes. It is just a mistake. So there are a total of 9 cards from 2 to 10. So because there are two suits of black color, so total cards are going to be 18. So required probability is 18 by 52. Right. So please keep this B question in your mind. This numbered thing normally like creates a lot of fuss. In third it says probability of it being a diamond. So now guys, diamond cards are total of 13 in number. So required probability is 13 by 52, which is 1 by 4. If we are required a red king, there are a total of 4 kings out of which only 2 are red. So required probability is going to be 2 by 52, which is 1 by 26. I hope these 4 cases are clear. Any doubt in these 4 cases? Tell me. Somewhere from 2 to 10, they are the numbered cards, right? From 2 to 10, there are a total of 9 numbered cards, right? So because there are two suits, two black suits, so which means there are a total of 9 into 2, 18 black numbered card. Likewise, there are going to be a total of 18 red numbered card. Is it done somewhere? So required probability is 18 by 52. Okay, good, good. Now guys, be quick with your answers, but correct answers. Chinmay, you have to think. Everything is written in the question itself. Okay, guys, let's do it. Right, Shubhadeep. Right. Right, Rishabh. So, guys, here the question says two cards are drawn simultaneously. So, Chinmay, when he says two cards are drawn simultaneously, it means it is in one go, you can say. So, find the probability of both being kings. So, I know that there are a total of four kings, out of which I am required two kings. In this case, out of 52 cards, you are taking out two cards, right? So on solving this, it becomes 4 into 3 divided by 52 into 51. This is one way of looking at it. Or I can say, when I am going to draw my first card, so as I am required a king, so required probability for first will be out of 4, any king comes to me. Right, so required probability for first being a king is 4 by 52. Because we have taken out that card, for second card it is going to be 3 by 51. Is it clear, everyone? So it can be represented in this way or in this way. Either ways it is the same. We just need to focus on the logic. Guys, is it clear? Okay. So we will be doing it slowly and steadily. For B, so guys, tell me how many honor card are there? Total number of honor cards. Okay, Subhadeep, that's why I said we will be doing it slowly and steadily. A, J, Q, K. For every suit, there are 4 honor cards, which makes it a total of 16 honor cards. So we are required both the cards, which should be honor cards. So required probability is going to be 16C2 upon 52C2. In third, he says we are required black honor cards. So there are a total of 8 black honor cards. So required probability is going to be 8C2 divided by 52C2. Guys, is it clear to each and every student all three questions? Tell me, Shivani, what is the doubt? Shivani, there are a total of 4 kings. Out of 4 kings, I am required 2 kings. They are my favorable cases. On the other side, out of 52 cards, you have to draw 2 cards. So out of 52, 2 things can be selected in 52 C2 ways. Out of 4 kings, 2 can be selected in 4C 2 ways. That's it. Tell me, Shivani, what is the confusion? Because question says you have to draw 2 cards. Right? Question says you have to draw 2 cards. So you will be drawing 2 out of 4. They are the favorable cases. Likewise in B and C. For each suit, there are 4 honor cards. As we have a total of 4 suits, so total number of honor cards are 16, out of which we have to select 2. They are my favorable cases. Out of total cases, wherein if you select any 2 cards out of 52, just wait, Krishan. Is it done, Shivani? Likewise for third. So in third case, there are 8 honor cards which are black in color. We have to select 2 cards. So likewise, out of 52, you just select 2. That is your sample space. Done. Okay, now guys, let's do one question which is asked by question. So I am reframing it. So let's say the question is, 2 cards are drawn from 2 well shuffled pack of cards. Find the probability of both being kings. So tell me the answer for question number 1. Come on guys, be quick. Okay, let's do it. I got many responses. So when 2 cards are drawn from 2 pack of cards, first of all, it is not stated whether we are going to take out 2 cards from 1 pack only or it is one card from both. So we have to consider all the cases, right? So if you take out 2 cards from first pack, if you take out one from first and second from second pack, or if you take out 2 from second pack only, they are the possibilities which we need to observe, right? So like if you take out both the cards from first pack, so we have already discussed the probability that it is 4C2 divided by 52C2. If I take out one of the card from first and second from second, in that case the probability is going to be 4 by 52 into 4 by 52. Likewise, if you take out both the cards from the third pack, sorry, from the second pack, so again it is going to be 4C2 upon 52C2. Is it clear, everyone? Which one, Shubhadi? Yes, yes, yes. Guys, this part is to be multiplied by 2 also, because there are going to be 2 possibilities. Like if you get, uh, let's say, club on first and diamond on second, it can be other way around also. So it is to be multiplied by 2 also. So on adding all the 3, I will be getting my final answer. Is it done, Krishan? Sharad, because in this case, in second case, it is not specified from which pack you are drawing which card, right? As we did in the previous question also. Yes, Sharad, because in this case, it will matter that whether you are taking club from first and diamond from second, or it is diamond from first and club from second. Because again, their suit is going to be different. That's why we have to consider all the possibilities. Is it done? Okay, guys, let's move on to next. So now Few more things which we need to understand in case of this probabilities, which are mutually exclusive events and which are collectively exhaustive events. So I have written the definition so that we can understand this thing thoroughly. That if there is a set of events such that if any one of them occurs, none of the other can occur. The events are said to be mutually exclusive. So let's say if there is a dice which is thrown, so we all know that the numbers on the dice are 1, 2, 3, 4, 5, 6. So let's say an event has taken place wherein you got 1 on the top face of the dice. When you have thrown a dice only once. If you throw a dice, let's say 2 times, right? So we get another event wherein the numbers we got were 2 and 3 on the top face of the dice. On the other side, you throw dice again and you get an event wherein the numbers were 4 and 5 on the top face of the dice. So here we can say that these three events are mutually exclusive events. That if any one of them occurs, none of the other can occur. If we get 1 on the top face of the dice, Sharad, I said if you throw them two times, right? Or if you get either 2 or 3, you can also consider it that way. Another event is when you throw it 2 times, when you get 4 or 5, or like if I say that there is an event wherein you can get 4 and 5 only. And here I'm saying they are mutually exclusive events. Please keep this thing in your mind, right? So if this thing is happening, these things cannot happen. You can get only one of the number on the top face of the dice. If it is 1, it is 1. If you get 2 and 3, or if you get 2 or 3, it is 2 and 3 or 2 or 3 only. Nothing else can come out of other events which we have described. Is it clear, everyone? And collectively exhaustive events are there that if there is a set of events such that at least one of them is bound to occur. So please keep in mind, if there is a set of events such that at least one of them is bound to occur, the events are said to be collectively exhaustive. So in this case, let's say like if again you throw dice multiple number of times and one of the event is that you got numbers 1, 2, 3. Another event took place wherein the numbers you got are 2, 4, 5. If at least one of the value is repeating, then we can say that they are collectively exhaustive events. So this thing is very helpful in understanding one part, which is that if a set of events are both mutually exclusive and collectively exhaustive, the sum of their probabilities is 1. If they are not mutually exclusive and collectively exhaustive, then sum of their probabilities we cannot take as 1. Is it clear, everyone? So what we were doing in the previous questions were because of this only. When we have to take complement, the complement comes into picture when the events are mutually exclusive, or you can say collectively exhaustive along with it. Is it clear, everyone? Okay, okay, good. So now on the other side, the basic concept which you guys have studied in case of Venn diagram is also applicable in case of probability. If A and B are two events, then probability A union B equals probability of A taking place plus probability of event B taking place minus probability of A and B taking place. Right? Like if we take an example that if a die is rolled, what is the probability that the number that comes up is either even or prime? So as we know, out of 1, 2, 3, 4, 5, 6, one way of looking at this information is straightways that the number required is even or prime, right? So guys, how many favorable cases are there such that the number is either even or prime? So be quick guys, how many numbers are there, how many favorable cases are there that the number is either even or prime? Right, Saurabh, right, right, Saurabh. Okay, so guys, wait. Many are wrong answers, many are wrong answers. So this or means union. Had the statement been that what is the probability that the number comes up is even and prime, or if the statement is even prime number, right? Or if the statement says even as well as prime, then they basically means intersection of the two categories. So this or means union. So when it comes to even, so in that case, even numbers are 2, 4, 6. When it comes to prime, prime numbers are 2, 3 and 5. The union of all is going to be 2, 3, 4, 5, 6. So there are 5 possibilities out of 6 wherein the number is either even or prime. If I talk about PA, right, if I consider it to be, let's say, even and this to be prime. So probability that the number is even is 1 by 2. Probability that the number is this prime is again 1 by 2 minus probability that the number is even and prime. So there is only one number which is even as well as prime. So that is 1 by 6. So if you solve it, you can see that left hand side equals right hand side. So in the question, straightways, it is not mandatory that it comes in this form of statement only, right? It can also be that if A and B are the only two events which took place, and if P A union B is some number given to you, P A is given to you, P B is given to you, and it says find the value of P A intersection B. So this is what we have to apply straightways. I hope guys this part is clear to all. So in the previous year, one direct question has come on this concept only. So everyone should be comfortable with this formula. Please always keep in mind it is out of Venn diagram only, nothing new. Is it done? Any doubt in this? Tell me. Okay, then let's move on to next. So answer both the questions. Be quick. Okay, guys, let's take a break. It's already 9:10. Leave it because your next class is about to start. So I will be discussing it in next class. So let's keep it up to this thing only, right? Because it's already 9:10. The case sir must be waiting for you. So guys, I'm signing off. Good night. So we'll meet you in next class. Good night. Good night, everyone. Good night. Good night. Good night. Thank you. Thank you. Good night. Good night.